Here's an example of graphing a linear inequality. We have x minus 2y is strictly less than 8. We're looking for the infinite number of ordered pairs x comma y such that those are less than 8. So let's go ahead and graph this. First thing we need to graph is actually a boundary line between the true and the false ordered pairs. And you can graph this any way you want. You can use intercept, slope-intercept form, anything like that. I'm just going to go ahead and graph the intercepts. 8 comma 0 is the x-intercept, and the y-intercept is 0, negative 4. So let's label those here, knowing that we're going to graph those. Now, one thing you have to be careful about when you're graphing the boundary line here is because we have strictly less than, we have to use a dotted line to represent the fact that points on our boundary line are not included in our solution. So that's a very important part of graphing linear inequalities. Now, we need to decide which side of the line, is it the upper left or the lower right, that gives us our infinite number of true statements. Well, let's just take a little test point here. A good one, my favorite, is the origin. So the test point 0 comma 0 is a good one to plug back into the original inequality. And from this we have 0 minus 0, which is less than 8. 0 is less than 8. That's certainly a true statement. So what that means is every ordered pair above and to the left of this line, and not including that line, will give us a true statement for our inequality. So this is what the solution for this inequality looks like once we've graphed it entirely.